Hello students, today we are going to discuss about a new concept, okay, that is friction. Okay, so what is friction? So in previous lectures you already know that what is force. So any type of push or pull is known as force, and basically the forces are divided into two categories. One is contact force and the other one is field force. Okay, so basically what is a contact force? The force which applies only when there is a type of physical contact between any two surfaces. Okay, when there is a physical contact in between any two surfaces, for example this is a surface and this is my another hand. So when these two palms are in contact, there is a force acting in between these two contact surfaces, and this type of force is known as contact force. Clear? So whenever there is any kind of physical contact between any two different bodies, they will exert a force on each other, and that type of forces are known as contact forces. Clear? Similarly, what is field force? So field force are those type of forces which never require any kind of physical contact. For example, I just drop a piece of chalk from this level and it suddenly goes down. That means if this piece of chalk goes down from this height to this height, there must be a force which is applying on this piece of chalk, and that type of force is known as field force, because there is no physical contact between this hand and this hand. So when I drop a chalk, it suddenly goes down. That means a attractive force attract this piece of chalk from this height for which it goes down, and this type of force which never require any kind of physical contact are known as field forces. Clear? Like the gravitational force which is responsible for this case. Clear? So now we are going to discuss only about the contact forces. So all the contact forces, that means whenever there is two surfaces are in contact. For example, if I am considering a block here and here is another block. Okay, so in this case these two blocks A and B are in physical contact with each other. That means at this portion where the two blocks are in contact, there must be a contact force acting on each other. Clear? And basically here the contact force is acting on each other. Okay, and if I am applying any type of push or external force, pull force, then this type of force is also known as a contact force, because to apply this force F, I need a contact with this block. So whenever there is a actual physical contact required to apply a force, then that kind of force is known as contact force. Clear? So here the contact force between any two surfaces can be along any direction. For example, if I am considering here is a surface and here is another surface of two body, here is a body A and here is another body B. So at this point, here the point, these are certain points where the bodies are in contact. So at the point of contact, these bodies applied certain force. If this is the force due to the contact, this is the force F due to contact, and here this is the force F due to contact. So these forces which are experienced by these two contact surfaces due to the physical contact between the surfaces are known as contact forces, and these contact forces have two components. Okay, if this is the net contact force at this point, so it has two components. One is along horizontal direction and the other one is vertical direction. Clear? Similarly, at this place it also has a component along horizontal direction and another component along vertical direction. So at each and every point of contact between two surfaces, there is a contact force exists, and the contact force have two components. One is along vertical direction and the other component is along horizontal direction. So the component of the contact force which is vertical to the contact surface is known as normal reaction force. We already studied about it in previous class lecture, that is in case of laws of motion. So this is known as normal force. Okay, so each and every point, the component of the contact force which is vertically or perpendicular to the point of contact or the contact surface is known as normal force. Okay, so normal force is basically a component of contact force, and the component of the contact force which is horizontal or tangent to the contact surface is known as friction or frictional force. Clear? So we already studied about the normal force in laws of motion. Now we are going to discuss about this tangential component of the contact force which is known as frictional force. Okay, clear? So what is frictional force? It is the tangential component of the contact force which acts tangent to the contact surface when two bodies are in contact. Clear? So the tangential component of the net contact force is known as frictional force. So frictional force is what type of force? It is a contact force. Clear? So here we can write certain point regarding the frictional force. It is a contact force. Okay, it acts tangentially to the contact surface. Okay, and basically it is a electromagnetic force. Okay, so frictional force is a contact force which is acts tangentially to the contact surface, and it is basically a electromagnetic force. So the frictional force or contact force is originated due to the electromagnetic force experienced by the different molecules or atoms of the two different bodies. Clear? So we basically have an idea now what is friction and what type of force it is. So generally friction can be of different types. Okay, so the frictional force can be of different types. Depending upon type of surfaces in contact. Okay, so basically it can act in solid surface, liquid surface, and also with solid liquid surface. Okay, solid surface frictional force generally known as dry friction. Okay, but when the friction force exists between solid and liquid surface or liquid surface, these are basically known as wet friction. And the frictional force which exists between liquid surface is generally known as viscosity. We will discuss about these two cases in later classes, but in this lecture we are only concentrated about this type of friction which exists in between two solid surfaces. Whenever two solid surfaces are in contact, there is a contact force, and the tangential component of that contact force is known as frictional force. So we only discuss now whenever there is two solid surfaces are in contact, then what type of frictional force acts on them, we will discuss it. Okay. So now we can write friction between two solid contact surfaces. Okay. So there are different types of frictional force act between whenever there is two solid surfaces in contact, and the types of frictional force are kinetic friction, static friction, okay. So what is kinetic friction? So the word kinetic means what? When there is any kind of motion. So when two surfaces are in contact, for example, this is a block named as B and this is another block named as A. Okay. So when the block A is moved along this direction with certain velocity V, okay, with respect to the block B, if the block B is on the ground surface and it is at rest, okay, so if the block A is moving with certain velocity V, then there is a relative motion of A with respect to B. So we can write relative velocity of A with respect to B is how much? V, because with respect to B, the block A is moving along this direction with V. So there is a relative motion between these two blocks. So as these two blocks are in contact with this region, so there is must be a contact force experiencing by these two blocks, and the tangential component of the contact force is known as the frictional force. So here, as there is a relative motion between these two blocks, so if there is acting a frictional force which is denoted by Fr, then the type of frictional force is known as what? Kinetic friction. Okay, because there is some motion between these two blocks. Okay, so whenever two blocks are in contact and there is a relative motion between these two surfaces or blocks, then at that instant the force of friction which is experienced by both the blocks at the region of contact is known as kinetic friction. So here the frictional force which is experienced by both the blocks due to the relative motion between these two blocks are known as kinetic friction. Okay, so kinetic friction is what? Whenever there is a relative motion between two surfaces in contact, then the frictional force experienced by both the contact surfaces or contact bodies is known as kinetic friction. Okay, and what is the action of friction? So you have to remember that the frictional force always tries to oppose the relative motion between both the contact surfaces. Clear? So here we can write the it always tries oppose the relative motion between the contact bodies. Okay, so here in this case, if the velocity of block A with respect to B, as B is at rest, with respect to B is along this direction, so as the block A is moved along this direction, so the frictional force which is exist in between these two contact surfaces act in such a way that it always try to oppose the relative motion. So as the block is moving along this direction with respect to B, so the frictional force always wants that the block A can't move along this direction with respect to B, so it always acts along this direction, so that the relative motion between A and B is opposed. Or else, if we are considering the motion of B with respect to A, here the B is at rest and the block A is moving along this direction, so B is what? The relative velocity of A with respect to B, which is along this direction. So the frictional force experienced by A with respect to B is along this direction, because this force always tries to oppose the relative motion. So the frictional force experienced by block A with respect to B is along this direction, and as here there is a relative motion, so the type of frictional force is known as kinetic frictional force. But if someone standing on block A, if here is a person which is observing the motion from the frame of reference of block A, that means if a body or if a observer is sitting on block A, so what is the velocity of block B with respect to A? In ground frame, block B is at rest, or if we are sitting on the block B, then we can observe that the block A is moving along this direction, which is velocity of A with respect to B. So the frictional force acting on block A by the block B is along this direction, and as there is a relative motion, that means the blocks are already moving with respect to each other. That's why the friction is known as kinetic friction. Okay, but if someone is sitting on block A, so for him block A is known as the frame of reference. So from block A he has to observe the motion. So for the person who is sitting on block A, as this is the frame of reference and which is moving along this direction, so for the person or observer which is sitting on block A, he observed that the block B is moving backward direction with the same velocity VA. Okay. So for the observer who is sitting on block A observes that the block B is moving backward with velocity V. That means this is the velocity of B with respect to A. So as the block B is moving backward with respect to A, so the block A apply a force of friction on the contact surface of the block B, and the nature of the force of friction is what? To oppose the relative motion. That's why when the block A observes that the block B is moving along this direction, so this block A applies a force of friction on the block B in such a way that the relative motion get opposed. That means the frictional force which is applied by A on B will be in this direction. Okay, because with respect to A, the block B is moving along this direction, but in ground case or in reality, B is at rest, A is moving along this direction. But as the frame of reference changes, so the motion observed by the observer will get changed. So according to the observer which is sitting on A, observed that the block B is moving in backward direction. That's why the frictional force which is experienced by B due to A will in such a way that it will oppose the relative motion. That's why the frictional force Fr which is act on block B by A will be in this direction. Clear? And as there is already a relative motion between these two occurs, so the type of frictional force is known as what? Kinetic friction. Okay. So now we can easily determine the direction of frictional force acting on different blocks. Clear? So first of all, how to find out what kind of frictional force it is? If there is a relative motion between the contact surfaces, then by the nature of the surface there exists a frictional force, and if the relative motion occurs, then that type of frictional force is known as kinetic frictional force, and the direction of the frictional force will be in such a way that it always tries to oppose the relative motion between the contact surfaces. Clear? With respect to the body which is applying the frictional force. As here, when we observe the motion with respect to A, so according to the relative motion with respect to A, the block A will apply a frictional force on block B to oppose the relative motion. Similarly, when we observe the same motion with respect to block B, so according to the relative motion of the contact bodies with respect to B, the block B will apply a frictional force on block A to oppose the relative motion. Clear? So now I think you already understood what is kinetic friction and how it acts and how we can find out the direction of what the kinetic friction. So here as we observe that whenever there is a two bodies in contact, so frictional force acts on two surfaces or on two bodies. As here we observe that the frictional force on block A due to B is along this direction, and similarly the frictional force on block B due to A is along this direction. These two forces are action reaction pair. Okay, their magnitude equals but direction is opposite. Clear? So this frictional force which is acting on B by the block A is magnitude equal with the force acting on block A by B, but the direction are opposite. Clear? So this is the frictional force which is known as kinetic friction. So what is the magnitude or value of this kinetic friction? So the magnitude of the kinetic friction or the kinetic frictional force between two contact surfaces can be written as, if this is the F kinetic, I am writing here the frictional force due when it is there is a relative motion, that is known as F kinetic, can be written as some constant mu k into the normal reaction force. Okay, so here what is mu k? So mu k is known as the coefficient of kinetic friction. And what is N? It is known as the normal reaction force. Okay, and the direction we can easily find out in such a way that it always tries to what? Oppose the relative motion. So the direction of the frictional force will be in such a way that it always tries to oppose the relative motion between the contact surface. Okay, clear? You have to remember this formula. Okay, what is mu k? It is known as the coefficient of kinetic friction and it's a dimensionless quantity. Okay, because here this is a force and normal reaction is also a force, so mu k is a dimensionless quantity and has no unit. Clear? So next we are going to discuss about what is static friction. So as here the name contains the word static, means rest. So whenever there is two bodies in contact, similarly here is the block A and block B, they are placed on a surface. Okay, and I am applying a force on this block A along this direction. Okay, so if block B is at rest, but I am applying a force F on block A, so the block A will start move along block B, but it was observed that the block A is not moving That means according to Newton's second law, whenever there is a external force acting on any body, if the mass of this block is let ma, clear? So it might have a acceleration because the applied force F can be written as mass of the block A into acceleration of block A. So we can write the acceleration of block A will be equal to F by m into A, clear? But as we observe, after applying the force F, there is no motion in block A. That means there must be another force which counters this external force, clear? But we are applying only one force. This is the external force that we are applying it on block A, but still the block is not moving. That means there is another force which counter this force, clear? And that force which oppose the motion due to this external force is frictional force, because here the blocks are in contact. So this is the contact surface, and as we already discussed, at the contact surface there is a contact force, and the contact force have two components. One is vertically, that is known as normal reaction force, and another one is tangentially or horizontally, that is known as frictional force. And the nature of frictional force is what? It always tries to oppose the relative motion. So as here we are applying a force F, but still there is no motion experienced by the block A. That means there is a force which is opposing this external force, and as there is no force, no motion, that means this block is already in rest even after the application of the external force F. That means the block is still in static position, there is no motion. Then the force which oppose this external force or effect of this external force is frictional force, and that frictional force is known as, here the frictional force which is acting Fr is called as static frictional or static friction. Okay, so when there is a external force applied on a body but still there is no motion observed, the system is at rest or in static position, then at that case the force of friction which oppose the relative motion is known as static frictional force, or the friction is known as static friction. Previously we studied what is kinetic friction. There is already relative motion, and the force which tries to oppose the relative motion is known as kinetic friction. Kinetic means there is a motion already, but in case of static friction there is no motion. The complete system is at rest even after application of an external force. Then at that instant the force which oppose the effect of this external force is known as static friction. Clear? So whenever there is no motion or the complete system is in static position, then at that case the force which oppose the effect of the external force which tries to create any kind of relative motion is known as static frictional force. Okay, so when there is no motion between two contact bodies, even after the application of an external force, then in that case the frictional force which oppose the motion is known as static frictional force, or simply the friction is known as static friction. Clear? as here there is no motion or the complete system is in static even after the application of the external force F, then at that instant the force of friction which is opposed the motion or the intention of the external force is known as static friction. Clear? So what is the magnitude of static friction? The magnitude of static friction, let this is be denoted by Fs, can be written as some constant mu s into the normal reaction force. So here what is mu s? Similarly, in case of previous kinetic friction, mu s is known as the coefficient of static friction. Okay, and we already know N is normal reaction force, and as both force, frictional force and normal reaction are two types of forces, so mu s is a unit and dimensionless constant. Clear? So now we already studied what is kinetic friction, how to find out the direction of kinetic friction, and what is static friction. So now we have to study how to find out the direction of static friction. So static friction only acts only when there is no motion exists between two contact surfaces. Okay, so you have to remember that the direction of the static frictional force is in such a way that it ensures that there is no motion within two contact bodies. Okay, so we can write that the direction of static frictional force will be in such a way that it ensures no motion between two contact bodies. Okay, and the magnitude we already discussed, that is mu s into n. Clear? So this is the types of frictional force exist between two solid surfaces in contact. One is frictional force, one is kinetic frictional force or kinetic friction, and the other one is static friction or static frictional force. Okay, so how we will calculate the value of kinetic friction and kinetic static friction, which is depends upon the coefficient of kinetic friction and coefficient of static friction, and that coefficient of, you have to remember certain laws which is known as laws of friction. So first point is that when there is no motion between two contact bodies, the friction is known as static friction. Okay, which can be given as the force of friction static is equal to mu s into n. Okay, next, when there is relative motion between two contact bodies, the friction is known as kinetic friction, which is defined by F kinetic equal to mu k into n. Clear? Then third point, the frictional force whether it is static or kinetic. Both F static and F kinetic is independent area of contact. It's an important point, you have to remember. The frictional force, both static and kinetic, is independent of area of contact as long as the normal reaction force remain constant. Okay, so whenever the normal reaction changes, the frictional force will change, but as long as the normal reaction remain constant, the frictional force, it can be static or kinetic, is independent of area of contact. Clear? Next point we can write here. The frictional force depends upon the nature of surfaces in contact. Okay, if the surface is smooth, then maybe the frictional force is small. If the surface is rough, then the frictional force may be more. So the frictional force depends upon the nature of surface in contact. Clear? So this is known as laws of friction, and we already studied what is frictional force, types of frictional force exist between two solid surfaces in contact, their magnitude, and how to find out the direction of the frictional force. Then the frictional force depends upon the types of or nature of the surface in contact, and it is independent of the area of contact until the normal reaction does not change. Okay. Okay, so we already know that when there is a relative motion exists between two contact surfaces, the frictional force is known as kinetic frictional force, and when there is no relative motion and there is no motion at all between two contact surfaces, the frictional force which oppose the effect of the external applied force is known as static frictional. Okay, so for example, here is a block which is present on a surface. Okay, it is a frictional surface, that means friction exists in between the block and the ground. Okay, so if I am applying a applied force Fa, okay, and this block has certain mass m. Okay, so as the force is applied on this block, so we already know according to the laws of motion or Newton's second law, the acceleration of the block can be written as the applied force divided by mass of the block. Clear? But it observed that even after the application of this force Fa, there is no motion within this block. That means we already discussed there is a frictional force which is acting on this block by the ground to oppose the effect of this external force A. So the force which acts to oppose this effect of the external force will be along this direction, and that is known as F static. Clear? So if we draw the free body diagram, here we will get a normal reaction acting on this block due to the ground frame, let it be N, and same amount of normal reaction which is acting on the ground due to the block will be along downward N. Clear? And as the block is placed over earth, if the surface is the surface of earth, then there will be a force of attraction due to the earth gravity, and that is known as weight of the block which is along this direction mg, and with same amount of force the block will attract earth towards it. Okay, we will discuss about in gravitation chapter, but now the force with which the block attracted by the earth towards its center is known as mg, and at this particular case, as there is no motion along vertical direction, that means the normal reaction exerted by the ground on the block will be equal to the weight of the block. So from the free body diagram we can write the normal reaction here, N equal to weight of the block mg, and as there are also no frictional force, there is no motion along horizontal direction, that means we can write Fa equal to how much? Fs. And we already know that what is Fs? Mu s into n. Clear? Okay. So as the frictional force is equal to mu s into n, so in this particular case, can we write that the applied force is equal to Fs, which is equal to mu s into n? Can we write like this? Here from the free body diagram we know there is no motion along vertical direction and no motion along horizontal direction. That means in vertical direction the both forces are equal and opposite. So we can write the normal reaction equal to mg. And similarly in horizontal direction there is two force. One is the applied force and the other one is the frictional force experienced by this block due to the ground. If here is the coefficient of static friction is mu s for these two contact surface. So what is frictional force? We already discussed, it will be mu s into normal reaction. So can we write at this particular case that the applied force is equal to Fs, which is equal to mu s into n? Or as here we can write n equal to mg. So can we write Fa, which is equal to frictional force, equal to mu s mg? Is it true? No. Okay, you have to remember that in this case, although the system is in equilibrium and at static case, the applied force is not equal to mu s into n. Okay, you have to remember that the mu s into n here, mu s into n is the maximum static frictional force can apply between two bodies in contact. Okay, so mu Sn is the maximum possible amount of static frictional force can applied between both the blocks or bodies in contact, but not always the value of frictional force when it is in static case is this much. Okay, so you have to remember that here mu s into n is the maximum static friction can applied between two bodies in contact. That does not mean that always the frictional force acting between these two surfaces is how much? Mu s n. This is the maximum possibility up to which the static friction can act. So here what is the value of static friction? Maybe it is this much or may not be. Okay, so here it can simply write as the static friction will be equal to Fa. That means the value of Fa is how much, accordingly the static frictional force can adjust itself. Okay, or you can say that the frictional force knows physics. Okay, the frictional force adjusts itself according to the value of F applied. Clear? So for example, if the mass, taking certain numerical values, I am explaining it. So you have to remember that here Fs is equal to how much? Mu s into n, which for this particular case is equal to mu s into mg, is the maximum frictional force, F maximum, that can be applied. But not always, it is not necessary that always the static frictional force is this much. Okay, so for example, I am considering a block here which have mass 1 kg. Okay, let here the frictional force is 0.1 or coefficient of static friction is 0.1, and I am applying a certain force F. We can vary this force, okay, according to our wish. So here from the free body diagram, what is the weight mg? If I am taking g at equal to 10, so mg will be 10 Newton, which is equivalent with the normal reaction exerted by the surface on the block, and the frictional force here is known as the Fs. Okay, so the maximum possible static friction will be how much? Mu s into n. So this implies for this particular case n equal to how much? Equal to 10 Newton, because it is in equilibrium case. So we can write 0.1 into 10, that is 1 Newton. So the maximum frictional force or static frictional force possible for this particular case is 1 Newton. That does not mean that always the static frictional force is 1 Newton. So for example, if I am considering Fa equal to 0.2 Newton. Clear? So if Fa equal to 0.2 Newton, so the maximum possibility of frictional force, static frictional force is how much? 1 Newton. So as here the applied force is 0.2 Newton, accordingly the static frictional force will adjust itself to this much quantity. Okay, so if the applied force is equal to 0.2 Newton, and as we know the maximum availability of static frictional force is 1 Newton, so for 0.2 Newton it can adjust itself to 0.2 Newton. So there will be no motion between the block and the ground. So for this particular case, if here I am writing Fa and here I am writing the frictional force, and this is the maximum possibility. So I am taking F applied equal to 0.2 Newton. So accordingly the static frictional force will adjust itself and it will become 0.2 Newton. Similarly, if I am increasing it up to 0.5 Newton, so as 0.5 Newton is less than the maximum value, so the static friction will adjust itself and it will become 0.5 Newton. Similarly, when I am taking it 0.9 Newton, again it is less than the maximum possible value, so it will adjust itself and it will again become 0.9 Newton. But when the applied force will become equal to the maximum value of the static friction, if I am taking it 10 Newton, then it is the maximum, 1 Newton. So then it will become the maximum value that can offer by these two contact surface to oppose the applied force. So at that case the frictional force will become equal to 1 Newton. If I am further increasing the value of applied force, I am taking it 1.1 Newton. So now the frictional force is not able to oppose this applied force, because the maximum possibility it can oppose is up to 1 Newton. So if I am applying 1.1 Newton, I am raising the value of the applied force 1.1 Newton, there will be motion. Clear? The body will not remain further in static case, because if I am taking the maximum value which is opposed, it's 1 Newton, and here I am applying 1.1 Newton. So there is a net force along horizontal direction which will be equal to how much? 0.1 Newton, and this can be written as mass of block A into acceleration. So from this we can get 0.1 Newton equal to mass of block is 1 into acceleration A. So A will be how much? 0.1 meter per second square. So there is a acceleration with which the body will move along this direction. So the body will start moving. Clear? So here the maximum limit for the static case is this one. Okay, this is the limit up to which the body will remain in static due to the maximum value of the static friction, and that particular value of the static friction, as here in this case, is known as limiting static friction. This is known as limiting static friction. Okay, so the maximum possibility of the static friction that particular value is known as limiting static friction. If we further increase the applied value, the body will start sliding and there will be a relative motion between these two contact forces. And we already discussed that whenever there is a relative motion between two contact forces, still there is a friction because the surface is not changing. Still the surface is same rough as before it is moving, and also the surface remains same when the body is sliding. But when the body is sliding, the type of frictional force will get changed from static to kinetic. So whenever I am further increasing the value of applied force from the limiting static frictional force, the body will start sliding, there is a move, and at that instant the frictional force which exists between these two contact surface is known as what? F kinetic, that is known as kinetic friction, and it's still moving with certain acceleration, that is known as F applied minus F kinetic equal to ma. So when there will be a motion, so we can write the force applied minus F kinetic equal to m into the acceleration of the body. Okay, so from this we will conclude what? The static friction or the frictional force can adjust itself according to the applied force, but up to a certain limit, and that maximum limit of the static frictional force is known as limiting static friction. Okay, below it the limit static frictional force value will be equivalent to the applied force. Okay, as we already studied here. But whenever the applied force cross the limit of the static friction or the limiting static frictional value, the frictional force will converted from static to kinetic, and it will remain constant because the body will start moving. So the kinetic frictional force is constant, but the static frictional force varies according to the applied force. Okay, so the kinetic frictional force at this particular case, we can write if the coefficient of kinetic friction here is mu k, let it be 0.05. So here the kinetic frictional force is constant, which can be written as how much? The kinetic frictional force for this particular case can be written as mu k into n. Okay, so if we plot a graph between the applied force and the frictional force, so the graph will look like this. Okay, here I am taking the frictional force and here I am taking the applied force. So as we already discussed, when the applied force is increasing, the static frictional force is also increasing up to a certain limit. So the graph will be a straight line like this. Okay, here the body is in static, and this is the maximum value for which the body will remain constant, that is known as what? Limiting static friction. Okay, so here the force just increase above this. Now the body will start sliding or moving, and you have to remember, after once the body starts sliding, if we decrease further the applied force to 1 Newton, from 1.1 to 1 Newton, still the body will start moving. Okay, once the body starts sliding or once the frictional force changes from static to kinetic, if we decrease the applied value slightly, then also the body will start moving. Clear? So if this is the limiting static friction, after that the body will start moving. So if we further decrease the applied force or if we further increase the applied force, the body will start moving with constant value, and the frictional force which is exist between the contact surface during the kinetic motion, that value is less than that of what? The limiting static friction. Okay, you can easily imagine that when there is a jam in a door and it's not opening easily, so you have to apply a large amount of force, but once the door open, you don't require to apply that much amount of force further. Okay, for example, if this is a box and I can't able to open it, it get jammed, so I have to apply a large amount of force to open it, but once it get opened, then it not required to apply that much amount of force to open it further. Same case happen in this case. Once the motion starts, then that limiting value force is not required to maintain the motion. we can decrease the applied force or the frictional force decrease by that limiting value. So this is known as the limiting case, but the kinetic friction which is exist throughout the motion and remain constant, here it is known as F kinetic, which will be mu k into n, is remain constant throughout the motion because the surface is not changing. So as the surface is frictional throughout the motion, so the kinetic friction will remain constant because there is no change in normal reaction and no change in type of surface. Clear? So you have to remember that the kinetic friction is slightly less than that of the limiting static friction. Okay, and limiting static friction is what? The maximum possible value of static friction, which can be mu s into n. So in this particular case, n is equal to mg. Okay, in this particular case, n equal to mg, but not always n equal to mg. So you never remember that F static equal to mu s into mg, it's wrong, or F kinetic equal to mu k into mg, these are wrong. Okay, because not always the normal reaction is equivalent to the weight of the block. That's why the formula for these two is what? The mu s is equal to mu s into the normal reaction, whatever may be the normal reaction at that particular case, and the kinetic frictional force will be mu k into the normal reaction. Okay, clear? And this is the graph between applied force and frictional force. The maximum opposition offered by the two surfaces in contact is known as limiting static friction, and we further increase the applied force, the value decreases and the body starts moving with certain motion or acceleration, and the frictional force remain constant throughout the motion, and that frictional force is known as what? Kinetic friction. Okay, so this is all about types of friction and how friction adjusts itself with respect to the external applied force, and what is limiting static friction, what is kinetic friction, and what is static friction. Okay, so next class we will discuss further. Thank you.